Hello, welcome back to NMI. In this video we're going to take a look at the CP400, a Brazilian clone of the TRS-80 Color Computer II. So here we have the CP400 Color II. This is a TRS-80 Color Computer II clone. This is a Brazilian clone manufactured by a company that was named ProLogica, right? This is the second version of their machines, right? It has, compared to the previous one, which I never owned, this one has a better keyboard, right? Both of them have these door here for cartridges, right? And on the back you have the connectors. You have a TV out, the channel selection, joystick, right and left, serial port, monitor port, cassette, on off, and external power supply, which in fact is just a transformer. Yeah, this brings back memories because I started with computers with a machine like this. Not exactly this one, because my machine, the one that I owned, that I got from my dad, is long gone. I found this for sale a couple months ago, and my brother brought it from Brazil when he visited me last year. So thanks, Nando. And this is it. This machine was sold as non-working, and I truly believe that it's not working. So in this video we're gonna take a look, check if it's working or not, and maybe try to fix it. I'm not sure I'm gonna be able to fix it on the first try, but let's see. I already removed the screws that are located on the back, right here, so we can proceed. This is the keyboard. I already disconnected the keyboard off camera, right? So you can see here, this is the the door, right? Not the trap door. This is the keyboard PCB, and here we have the circuitry. Maybe I'm gonna need to zoom in. Okay, so here we have a power supply and the main board, right? I can see here the 6809, the CPU, Motorola 6809. Here we see the memory management, right? This is the IC that is responsible for controlling the DRAM. Here we have the 64K of DRAM that was built in this machine. This is the 6847, the video generator. Two 6821s, the peripheral, the I/O ICs. Two EEPROMs here. So they're covered. Not sure if they're still good. As we, well, I don't know if you all know, but all these memories, the way they work, they have a life expectancy in terms of retaining the programming, right? And I believe that we are close or past the memory retention for, like, the data retention for these memories. So maybe the content is gone. I'm not sure. There are some other ICs. Oh, the MC1372. This is the chip that converts the video so that we can feed it here to this RF modulator, right? The TV channels. Oh, it's stuck? No, not really. But the channel selection is here. Yeah, what else we can see here? One thing that I can see already is that let me show you. We're gonna have to focus the camera. There's no marking on the PCB, right? You have here the manufacturer name and logo. Apparently this is a serial number here, 27402. There is a revision there, ProLogica 12 revision 3. But aside from that, this board was not designed to be maintained, right? There's no IC references, no component reference, to be honest. Yeah, see the resistors, the capacitors, there's no reference. On the PCB there are some here, C7. This is a 7805, so this is a 5-volt regulator. This is a switch mode regulator. We're gonna check the schematics to see what is happening here. So we can see here that the AC input comes here. There is a full bridge rectifier here. Yeah, big electrolytic capacitor, 4700 microfarads, 25 volts. A relay here. I believe this is for the cassette. The monitor out is here, and one of the wires here goes into this circuit that is, I don't know if this is a repair or this is some kind of mod. There is like something that, yeah, looks like a transistor, but it's a TO220 with a small tab. It's interesting. I saw one of these before, but they're not very common, I believe. Now, the next thing I'm gonna try to do is to power it up. I don't have the transformer. I don't have the original power. Oops, where is it? Here, power supply, right? I don't have it, so I'm gonna have to supply the power somehow. And the good news is that looking at the schematics, I can see that this bridge, after this bridge we see this capacitor, but on the schematics it is named C15, and here it is C7. So that is not so good news. But the first thing that I want to make sure is that this is the capacitor that is connected on the input after the rectifier bridge, because if it is this one, then we can simply apply like 12 volts here, and we're going to feed the whole circuitry. Because looking at the diagram of this power supply, we can see that the 7805 is located here, right? And the input comes directly from this electrolytic capacitor. And then the other switch mode IC here is generating -12 and -5. I believe this guy is here because the older generations of these machines, they were using memory chips that required negative voltage. And I believe that this -12 might be used for the serial interface, right? If we look here on the schematics, that, by the way, are in a very bad shape. That is the only one that I could find. But looking at the schematics, we can see that there's +5 here, +5. But here we can see on this IC, which is like an operational amplifier, +12 and -12, right? So, oh yeah, this is powering this. Oh, but this is not the same IC. This is IC 20 and this is 16. So yeah, so that voltage is coming here, right? Another thing that I was trying to find was the video output For some reason, this schematics doesn't show, like I was looking a lot, and I believe this is the RF modulator, because we see the channel selection here, but I could not find the connector for the monitor output clearly, right? But I found these references for a CN3, right? We have CN3 pin 5 here, CN3 pin 6, 4, 3, and pin 1 and pin 2 here. Maybe this is the video connector output, the monitor output. It could be, but I don't think so, because looking at another page on a Wikipedia, it shows the diagram, like the pin out of this monitor output, and it doesn't match this connector here, right? So I'm not too sure. This is definitely some kind of connector, but I don't know. And because there's nothing on the board, we don't know, right? I can see that the connector comes here. We see some wires going here, and one wire coming here, but that's it, right? There's no reference, no labeling, no nothing here, so it doesn't help. I'm gonna try, because looking at the diagrams, pin 1 and pin 7 here on this connector, they are the luminance and the video output signals, right? Pin 1 is this blue wire here, and pin 7 is the green wire here, right? That green wire that goes there. So this is maybe something that I can try to do. I also decided that first we're gonna measure here to make sure that this is the capacitor. If that is it, then I'm gonna use an external power supply to supply 12 volts. Okay, the DMM is there. Now let's use it. Okay, the beeper. So according to the power supply diagram, so the tab of the 7805 is ground, so they should be connected. Okay, yeah, that was expected. Now the input of the 7805 should be the same as the positive pin of the capacitor, and it is. So that's good news, right? So that means that we can supply 12 volts here, and we should be able to make the power supply work, and hopefully we're gonna see something, right? Maybe the machine is working, who knows? Okay, I enabled the camera showing the monitor and the power supply. I am gonna connect the power supply here. Ground is off, yeah. Capacitor. Now, fingers crossed, I'm gonna turn it on. Okay, 900 milliamps. I could hear the relay clicking. So there is something happening on this machine, because the machine appears to be working. Okay, so I'm gonna turn it off. I have that monitor in using the video input there, composite video. I have the audio input here and the video input. What I am gonna do is I'm gonna connect using these alligator clips. I'm gonna connect it here, right? I don't have the right video cable for this machine. I'm gonna have to, build one. For ground, I'm gonna use this switch. It's connected to the ground there. Oh, even better. Yeah, but I think the switch will do. And yeah, well, let's start with this luminance output, right? It's the easiest, most accessible one. Okay. Okay, now I'm gonna power it on. The monitor is on. Let's see what happens. Nothing. Okay. Let's try another ground. This guy here is connected to the ground, right? Or maybe, yeah, I don't know if this should be grounded, but this for sure is grounded, this resistor, because you can see something that resembles a ground plane. Okay, next try. Oh, okay. Good news. There is video signal. Nice. There is some sort of video signal is coming out of this machine. We should see a basic prompt, right? And some like basic versions and stuff. There's nothing there, but at least the video signal is being generated. So I believe that for that to happen, well, this guy is probably working, the CPU, and this guy is also probably working. I don't know about this mod, to be honest, or whatever this is. And I'm not too sure about these EEPROMs, right? Because I'm not sure the contents. Now, the next thing I'm going to do, I want to measure the voltages. There's another big ground here, right? So let's take a look. Where can we find here? We can find +5, right? Oops, +5. Yeah, we have +5. So the +5 volt is good. My bet is that there must be, or there could be, a problem with one of these DRAM here, right? There we have 8 DRAM chips, and obviously they are needed for any software to run. So maybe we have an issue with one of these guys. So the next thing I'm gonna do, I am gonna enable the scope. And okay, now we have the scope enabled. I want to have another ground because I need to connect the scope ground, and I don't want, yeah, we can have a, oh man, this 7508 is hot. Holy moly. And I am not sure, but I don't think that current, you see, 881 milliamps, it is really high. Of course, some of this current is going to this TL497 here, which is generating the negative voltages, right? But still, it's very high current, right? And I am afraid or concerned that maybe there is an IC here that is draining too much current, but I don't see anyone. Well, the DRAM controller here, the 74LS783, is more or warmer than the other ICs. That is a fact. But all the other ICs, yeah, there's no one really hot. Yeah, obviously I don't have a thermal camera, right? So yeah, that's all I can do. yeah, what I honestly, and even like this amount of current, I think these ICs are rated for 1 amp, so it's pretty close to the limit. And I'm wondering if, yeah, there is someone draining too much current, right? That, well, it would explain why it's hot, but it would not explain why the machine is not working, unless, obviously, yeah, if the IC is damaged, then it would drain more current and make the machine not work, right? But I don't know that yet. And my bet that one of these DRAMs, well, if one of them is bad, at least it's not hot, so there's no short or anything. One nice feature of this machine, well, kind of, right? Right now it's not very nice. The reset, let me show you. On other machines, like other Coco machines, the reset's usually on the back. Here we have 2 reset buttons, right? And if you press them together, you cause a reset. But obviously, nothing is gonna happen because the keyboard is not connected. Okay, so I'm gonna connect another ground, and I'm gonna try to make some measurements. Okay, I connected another ground to that resistor. This white wire here is the ground for the video. And I'm gonna connect my probe ground here. And now we should be good to go. So on the 6809E, the clock pins are these 2. E in and Q in, right? So this is something that I want to measure. We can also, I'm also interested on reset. VCC, we want to make sure that we have 5 volts there, so it's pin 7. And we also want to take a look at read and write, because you want to know that the IC or the CPU is trying to read and write memory, right? So let's get started. This is the CPU. Pin 1 is ground. It's 34. So before we power it, I'm gonna locate the pins. Pin 39. What is pin 39? There's a big track there, 39. Oh, that's the ground. It's grounded, but this is TSC. Not sure what is this pin doing. Okay, so 40, 39, 38, 37, 36. Oh, it's these 2 capacitors here. These are the 2 clock inputs. Okay, that's good. So I'm going to power it on. Okay. And let's see if we can see a clock. 900 kilohertz. Why the signal was dropping? The other one. It's funny that it is showing as a negative voltage. Is this really ground? Now I'm not too sure. Okay, so let's power it off. Continuity. Okay, and this is not ground. Crap. Okay. I thought it was ground, but it isn't. On the crystal here, this is ground. Okay, so let's use this crystal grounding here. Just, I'm concerned because there are too many components around it. Okay, I think this is safe. Okay, now power it on again. Oh, now we don't have any signal. That's funny. Current is the same. What is with this stream pot here? Nothing. That is funny. So if we have it here, there is some sort of video signal. Okay, maybe this, we shouldn't be using this one. So let's power it off. Let's use the proper ground. And I want to try that green wire there. Oh. Oh. Okay. This is better. Well, still, I believe the green is the right one there, but we don't have any character, we don't have any basic prompt, but this is good news. So what I'm gonna do, I'm gonna connect a pin on the connector so that we can use that signal. Okay, I have a DIN connector here. Maybe I should just build the cable, but not right now. So this is what I'm going to do. Okay, I have connected my video input signal here on the DIN connector. It's not touching anything that it shouldn't, like a ground, right? We're good to go. Let's power it on. Yep, okay, we have some video signal there. That's good. Now, let's take a look at those clock signals. Oh, now it's much better. Okay, so we have 893 kilohertz. And here we should see the same thing. They're just on different phases. Yeah, 893 kilohertz. That's good. What else we want to see? We want to take a look at reset, pin 37. So, 40, 39, 38, 37 there. Powered off. Yeah, it should not be grounded. It isn't. That's good. Now pin 32, we want to see, well, and we also want to see all the addresses line and all that stuff, right? So now then 7 is VCC. So okay, power it off, power it on, and we see, yeah, what is that? Yeah, 5 volts. Okay, and then 8 should be an address line. Okay, so 1 2 3 4 5 6 7 8. Okay, good. Yeah, we see some sort of signal here. Yeah, see, this is good news. So the CPU is generating addresses. Pin 9 A1, same thing. Pin 10. Oh, all the next pins are addresses. That's good. Okay. Everything I don't know, like I'm gonna say it looks good. It looks good from the perspective that the CPU appears to be generating addresses, right? Because that's what the CPU is expected to do: fetch instructions by putting the memory address on the address bus, and then where we want to see the, let's see, the read and write signal here. We need to find where the address decoder is decoding is happening, right? But anyway, we saw that 34 and 35 here. So this is 33, this is 32. Yeah, see, there is a read and write signal there. So that means that the CPU is performing operations, right, by reading and writing memory. We could, the reason it's not, the machine is not working could be one of two. Well, it can be more stuff, but I am still betting that the problem is one of the DRAMs, because you need the DRAM for the generating or the memory mapping, right, for the display. And in general, the CPU has only a few registers inside the chip, so it relies on like storing data on the external memory, on the DRAM in this case. But the other suspect could be this guy here, right? This guy is the one that manages the DRAM. So if this guy stops working, then it doesn't matter if the DRAM is good or not. It's not, the machine is not going to work. So we might want to take a look. The other problem that I see on this machine is that everything is soldered. There's no sockets anywhere. So if I want to try anything, I'm going to have to desolder the IC and replace it, right? And I don't have a spare for this LS783, so that's a bad thing. Because I don't have a spare, the first thing I would try is to replace the DRAMs, right? Before I start desoldering ICs and, you know, really going deeper into the motherboard, I decided to take a look. I have this is the TRS-80 Color Computer Technical Reference Manual. So this is the manual. Well, this is the original version of the one that I am using for the clone, for the Brazilian clone. And not to my surprise, most of the schematics, or to be honest, everything that I could find is basically the same, right? Since this is a copy, a clone. Maybe at some point later we can see there's some subtle differences, right? For instance, I think it's a nice addition that this machine has the monitor output. Another thing that I can see is that the cartridge connector, at least the size seems to be different, right? So I don't think the original cartridges fit here. For sure they don't fit on the physical size of the enclosure, but I think even the connector, I don't think it's the same. Another thing that I was looking for, because the Brazilian reference manual is the copy is very hard to read, right? So I was looking for more information on the circuitry that decodes the memory and like how the memory access happens. So we can see here, where is that? The SAM here, the dynamic memory management IC here, which in this case is the 74LS783, but in the original schematics is the MC6883. So this IC here, where is that? These three lines here, right? They go into this 328 decoder, and then here you have the memory selection, right? And when they are all zeros, you can see that it's selecting the internal RAM, the memory read here, right? The line Y1 here goes to the ROM expansion U28. The line Y2 goes to the internal ROM, which is U3. I'm not sure here which one is which. I don't think there is a real memory. I need to take a look these EEPROMs here. But anyway, what I need to see is like really the first line, and I want to check why and if the memories are being accessed. And here on sheet number 3, we can see here that, where is that? Memory read goes here, right? On the 74LS244. So it's probably enabling the pass-through when it's the memory is selected. So we can read the data out from the DRAM into the data bus, right? And here on this other diagram, here we can see that where is that? Pin 2 is the data in, and pin 14 is the data out. So one thing that I can do is to probe all the data outs here and see if I can find any DRAM that seems to be misbehaving, right? So as you can see, we have the video generation working in the same state. Now I'm going to start probing pin 14 of each DRAM. Here we have one. This one looks, I don't know, like I can't say that it's okay, but at least you can see that there is data going out, right? Next one. Okay. Next one. Okay. Next one. Okay. Now here. This one. Okay. This one. Yeah, okay. This one. Oh. Oh, this one is... Okay, so this DRAM, we don't see data out at all. That's a good sign. Maybe this is the culprit, right? And the last one, this is also working. So yeah, we have something to do. I'm gonna desolder this DRAM here and test it and maybe replace it if it's, well, I'm going to replace it anyway because we can see that it's not working properly. Maybe this is the faulty one. Let's see. Okay, so let's remove the PCB and desolder this memory and see what happens. There are more jumper wires here. There's another one here. Don't know if that is some sort of PCB fix. Okay, so we want to remove this memory here. So let's go. I'm gonna just apply some solder first. I believe it helps. And I like to wiggle a little bit the terminals once the solder on them is melted. I believe that also helps. Just found a damaged track. I'm gonna have to reconstruct. Let me see if I can show you. It's not on the same IC that I'm working on. This one here. I'm gonna have to reconstruct that track, but not now, because right now I need to remove that other memory. I believe the quality of this PCB is very bad. That's not gonna help me. Opa. Yep, now we are making progress. One side is... Oh, here we go. Hopefully I'm not removing any metallization. And here we have the IC, the DRAM. Yay! And I did not remove any metallization from what I see, which is a miracle considering that this board, I think the quality is not good. Now let's take a look here. Yeah, I'm gonna have to perform a thorough clean up because there are some particles. Dogs are barking upstairs. Apologize. Next step, we're gonna test this memory on a memory tester. So here we have my RAM jack. I bought this as part of an auction. Oh, it was already powered. Okay, test. Yeah, not good because it should see 6. We should see a 6 and a 4 for a 64K memory, which is this one. So okay, this memory is not good. So that's a good sign. That means that what I saw with the scope was in fact right, correct. Now I'm gonna get another 64K memory, and I'm gonna solder a socket there, and we're gonna install a new memory and see what happens. Here I have my memory storage, and we need 6. Oh, let me put my anti-static wrist 4164-12. That's faster than that one, but it's okay. Oh, I need more 64 DRAM. Don't have a lot. Anyway, for now, this is gonna suffice. I'm gonna take one. Let's get the memory tester again, just to make sure, right? Because some of these memories I bought from AliExpress, so there's a considerable... Whoa, I can't even see. There's no pin 1 marking? Really? I think from experience it's this side. Oh, nope, not good. Another one. Oh, see? This is what we wanted to see. 6-4. So this one is good. Oh, okay, at least one is good. Now I need a socket. I also need to reconstruct that track, right? That was, I don't know if it was me or, but anyway, now I need to fix that one. Okay. Oh, let me see on the top, but on the top I don't think there's any problem, no. So we're gonna install. Now, okay, so the track that is disconnected is this one here and here. Yeah, see? Yeah, it's not coming here, it ends here. So I need to rewire it. Okay, it's not gonna be so hard. Oh, I can just reconnect. The track is there. Let's see, just for testing now. Oh yeah, yeah, that's good enough for now, because now then we can test and see if it's working. So let me check again that memory here. Okay, still good. Now let's install. I'm just gonna use some alcohol to clean everything up here, just because I don't want any solder particle to mess up. Now let's install our DRAM here, and yeah, we need the bottom case here. I don't need to connect any of these, except I need the monitor here just to keep it in place. And we have here, and okay, now I'm gonna connect my DIN here, connect the video signal, gonna turn on the power. Everything is good. Yeah, let's see. Oh yes. Oh, you can see on the camera. Let me change it. Yep, it's working. Color Basic 1.0 ProLogica 1984. Amazing, pretty cool. So our diagnostics here were straight to the point, right? Hey, what about giving me a thumbs up and subscribing to my channel? Thank you. That DRAM was bad. I still don't like how hot this 7805 here gets, but there's nothing, I don't see anything other or like anything else wrong here, right? So that tells me that this is by design. This is why they have this big heat sink here. If we look at the power supply diagram of this one here, the clone here, the Brazilian clone, compared to the original one, you're gonna see that this power supply is much simpler. The other one is way well or better designed, right? So maybe that's another reason. Anyway, This maybe I'm gonna replace this 7805 later for switched mode 1 that is more efficient. But well, yeah, maybe I can replace the whole power supply, right? Because I'm not gonna need the -12 and -5. I need to check. I believe -12 is only used for the RS232. I'm not gonna use that for a while. Anyway, that's not the point right now. The point is we get our computer, my CP400 Color II is working again, and that is amazing. I'm super happy. I think this video is already too long, so I'm gonna make a follow-up video where I'm gonna, show you the machine working. I need to connect back the keyboard, and maybe I don't have any cartridge, unfortunately, not the ones that are compatible here. So maybe I'm gonna have to make something that we can feed audio via the cassette port. I'm not too sure, but anyway, at the very least I can write some quick basic program and we can see this machine working. And this is it. This is the CP400, the Brazilian Color Computer 2 clone. Thanks to my dad, because he bought me this machine. Thanks to my brother Nando, because he brought it to me. And if you're watching, you are one of the few watching my channel. Thanks for watching. Please subscribe to my channel, give me a thumbs up, and that is what makes me, keep doing videos and, trying to do cool stuff and showing to you. Thanks again, and see you next time. Bye.